Hello, friends. Second lecture series, video 2 in our solutions unit. After this video, you should be able to identify the key parts of a solution in more detail. Last video, we talked about the types of solutions: homogeneous and heterogeneous, colloid suspensions and solutions, proper and alloys, solutions and alloys. Now we're going to get into a little bit more of the key parts and how solutions behave. Okay, so our lead in here today is we know the different possible combinations, names, and properties: suspension, colloid, alloy, solution. What really sets solutions apart from the rest? Solutions are a key portion of this unit. That is the focus of this unit, and let's look a little deeper at what makes a solution a solution. Okay, so let's start on page 5 of our homework lecture here with characteristics of solutions. First of all solutions are homogeneous mixtures. The heterogeneous ones that we saw before were not solutions, they were colloids or suspensions. Clear as opposed to cloudy, and do not disperse light. There's this thing called Tyndall effect. I'm going to show you both in our lecture, and I'd love to show you in class as well, but I got to use my lasers, so be prepared. You can have color or be colorless if you're a solution. So you can be tinted, but you have to be clear without any cloudiness. They do not settle upon standing, or any amount of time. You can make a solution, and it will be a solution for the rest of eternity, assuming it doesn't dry up. It cannot be separated by filtration. So you pour a solution through a filter, it goes straight through the filter because it's completely homogeneous. The particles of it are so small they're at the atomic level. Cannot be separated by filter. So the bottom of page 5, we're going to talk about the Tyndall effect. It's not seen in solutions, even when a mixture makes a beam of light visible. So this Tyndall effect here is a picture. This is showing that is not a solution because you can see the laser going through this beaker. Now, water, pure water, distilled water, is not a solution because it's got nothing in it, and the beam would go straight through. This stuff is a solution because that light beam is seen through the beaker. You really got to see this in person, so be prepared for my demonstrations in class and make sure that you get a chance to see that Tyndall effect. It's one of those things you just got to see. So, solutions always assume the phase of the solvent. We are on to page 6 in our lecture pack. Solutions always assume the phase of the solvent. The solvent does the dissolving, and the solute gets dissolved. So if we have a phase of the solute, which is the stuff that's getting dissolved, if it's solid and you mix it into a solid, the example that we're talking about will be a metallic alloy. I have a demonstration for you of this as well. You will see how I mix two solids together with heat, and we get an alloy. Now, if I have a solid solute, which would be like salt or sugar, and I add it to a liquid like water, we're going to make something like table salt and water. The water will cause the salt to dissolve, and it will be a liquid because the phase of the solvent is what the solution takes on. It takes on the phase of the solvent. So if I mix a liquid with another liquid, we're going to get a liquid solution. So it's like mixing alcohol and water. Rubbing alcohol that you put on cuts is a solution of isopropyl alcohol and water. Now, if I have a gas mixed in with a liquid, it's going to take on the phase of the solvent, so it's going to be a liquid, but this is like your CO2 in the water, like club soda or any carbonated beverage. The gas is dissolved in the liquid, and once you pop the top, the pressure is released and the gas can bubble out. Now, the other situation is the last one, is gas dissolved in another gas. You're breathing it right now. Air in the atmosphere is a solution. Oxygen, nitrogen, carbon dioxide, methane, all the other gases in our atmosphere all mixed together to make a solution we call air. So air is the solution that we breathe, and our body takes the oxygen out of it. So again, we always take the phase of the solvent when we're talking about solutions. Now, solutions are made up of two parts. I've been talking about solvents and solutes. Here's the definitions. A solute is a substance or substance that are getting dissolved. So they get dissolved in solution. Example, the salt in salt water. You take the salt, you add some water, the salt gets dissolved. The solute is usually a solid. It's usually a solid. Sometimes it could be a liquid. So, and it's definitely the lesser quantity of the two. So I have a tiny little pie of salt, big beaker of water. The salt is the solute. Now the solvent is doing the dissolving. So dissolved, dissolving. These are verbs, I think. Asking an English teacher. The solute, example, the water in the salt water, is usually a liquid and is the greater quantity of the two versus a solute. Okay, so it's the greater quantity is the solvent, and it's usually a liquid, period. Moving on. So we still at the bottom of page 6 here, we got some pictures of what the solute and solvent is. The act of a solute becoming dissolved is called solvation, but we don't really need to know that. Solvent and solution. So you got the solute, a little bit. That's a little bitty bit. And the solvent is a lot of it. And together we get a solution. Now, there's a special term for that, bottom of page 6, and we call that aqueous, a solution in which water is a solvent. And we always put a nice symbol here after that. So if I said NaCl aqueous, that means this is NaCl dissolved in water. So that's what the AQ means. It's much easier for me to write AQ than it is for me to write all that. That's why we came up with the symbol. So NaClAQ is otherwise known as salt water, is actually Na plus and Cl negative, because these things, the ionic compounds, break apart into their ions when they're in an aqueous situation. So let's see what else we got here. That brings us to the end of page 6 and the end of this lecture. There's no practice and no quiz, but you should be able to identify the important parts of the solutions now. So phase of the solute and the solvent, how it all works together to make a solution. And that symbol AQ, that's also a very important one. So do not go looking on Castle for a quiz, but do take care of your lecture notes too. You checked it off, stamp it, sign it, get it done, and move on to lecture 3. Thanks for watching.